Welcome to Biology My Passion. I am Soumya Harikrishna. Today we will do certain numericals based on refractive index, lens and power of lens. Our first question, the velocity of light in water is 2.25 into 10 to the power of 8 meter per second. If the speed of light in vacuum be 3 into 10 to the power of 8 meter per second, find the refractive index of water. So here one of the media is vacuum or air. So in such case, which formula can we use? N is equal to C upon V. Here N is the refractive index of the medium, C is the velocity of light in air or vacuum, and V is the velocity of the light in the given medium. So here V is given. What is V? V is equal to 2.25 into 10 to the power of 8 meter per second. C already we know, but it is also given in the question, 3 into 10 to the power of 8 meter per second. Now we have to find out N. We can substitute C and V. 3 into 10 raised to 8 upon 2.25 into 10 raised to 8. These two values can be cancelled. Here to remove the decimal place, two decimal places are there. So we can multiply by 100. But if you multiply the denominator by 100, numerator also you will have to multiply. So 300 by 225. So with the 25 we can cancel this. That is 12. Here it is 9. So if you cancel this, 4 and 3. So 4 by 3 is N, that is 1.33. So the refractive index of the medium is 1.33. The second question, velocity of light in air is 3 into 10 raised to 8 meter per second. So C is given. Calculate the velocity of light in glass, that is Vg we have to find out. If the refractive index of glass is 1.5, N is given. So since the one medium is air, we can write it as N is equal to C upon V. We have N is equal to 1.5. C is equal to 3 into 10 to the power of 8 meter per second. So V can be found out by the formula C upon N, that is 3 into 10 raised to 8 meter per second upon 1.5. This we will get 2. So 2 into 10 raised to 8 meter per second is the velocity of light in glass. A converging lens of focal length 5 cm. Converging lens is a convex lens. So focal length is 5 cm, is placed at a distance of 20 cm from a screen. So image distance is given. How far from the lens should an object be placed so as to form real image on the screen? So here we have to find out U. F is given. F is equal to 5 cm. Since it is convex mirror, it is positive only. Whereas V is given, that is 20 cm. We know in the case of convex lens, real images are formed on the other side of the lens, so it will be positive. Now U is supposed to be found. So the formula is 1 by F is equal to 1 by V minus 1 by U. This is the lens formula. So we are supposed to find out U. So if you find out U, bring this side, and so minus 1 by U will become plus 1 by U. But this 1 by V and F will go that side, becomes minus. So if you substitute the values, 1 by 20 minus 1 by 5. So what is the LCM? 20. So 1 minus 4. So minus 3 upon 20. Therefore U is equal to minus 20 upon 3. So if you cancel this, you will get 6.66 centimeter. That is the object distance. So the object should be placed 6.66 centimeter in front of the convex mirror. In such questions, since it is asked, it's better to write in words whether the nature of the image or the magnification, everything you can write the conclusion like this. A concave lens has focal length 15 centimeter. So F is given. At what distance should an object U from the lens be placed so that it forms an image at 10 centimeters? So V is given from the lens. Also find the magnification of lens. So here f is equal to minus 15 centimeter, because we know that the focal length of concave lens is negative and V is also given 10 centimeter. In the case of concave lens, the virtual images are formed on the same side of the object or in front of the lens, so it is always negative. So how to find out U? We can use the lens formula, that is 1 by F is equal to 1 by V minus 1 by U. 1 by U is equal to 1 by V minus 1 by F. So 1 by V is 1 by minus 10 minus 1 by minus 50. So 1 by minus 10 plus 1 by 50. So if you take LCM 30, this is minus 3 plus 2 minus 1 by 30. Therefore U is equal to minus 30 centimeter. Also find the magnification of the lens. So we have to use the formula magnification is equal to V by U. So V is equal to minus 10 upon U is equal to minus 30. So what is the answer? 1 by 3. Minus and minus will become plus 1 by 3. So magnification is 0.33. If you divide, you will get 0.33. So if you analyze this, this is a positive value. So what kind of image is this? Virtual and right? Because concave, we have to get positive. And 0.33 means what? It is diminished image. Less than 1. 0.33 is less than 1. So it is a virtual, erect and diminished image. Image nature is not asked, only magnification is asked. I just told you for your information. Next question is based on power. Power of a lens is plus 0.4 diopter. Unit of power is diopter. What kind of lens is it and what is its focal length? So we know that focal length is equal to reciprocal of power, right? So what is it? 1 by 4. 1 by 4 is 0.25. In meters only we get focal length. So if you make it into centimeter, it is 25 centimeter. Here it is a convex lens. How can we say it is convex lens? Because power and focal length both are positive. When a ray of light passes from a denser to rarer medium, which angle is greater, angle I or angle R? So here this is the normal, this is the plane. If an angle of a ray is falling at an angle here, that is angle I, and it is from denser to rarer. So the normal is like this, it has to go like this. But since it is coming from denser to rarer, it will move away from the normal. So angle I is smaller than angle R. So which is greater? Angle R will be greater. What is angle I when light is incident normally on the surface of separation of two media? Suppose this is the plane, this is the normal. Suppose the light is falling over this. So when it is falling over this, actually the angle I or the angle of incidence is the angle between the normal and the incident ray. But here both are falling on over the other or the same plane. So there is no angle. So it is 0. So the angle I will be 0 in this case. If the image formed by a lens is always diminished and erect, what is the nature of the lens? So we know that concave lens only produces diminished, virtual and erect images, whereas convex lens always produce real image or virtual image, diminished, same size or enlarged images. 3 light rays incident at the same angle of 30 degree with respect to the normal at the same side of 3 transparent glass slabs ABC of same dimensions having refractive indices 1.48, 1.55 and 1.62 respectively, in which glass slab ray undergoes maximum and a minimum lateral displacement. We know that if an incident ray is falling here, making an angle with the normal, it is supposed to go straight if there was no glass slab, but due to refraction, the refracted ray will bend towards the normal since it is entering from air to glass, which is rarer to denser. At this place, again there is a normal. Now the ray will be going away from the normal, making a distance between the actual path, which was supposed to be if there was no glass slab, and the new path. So this displacement in the light ray is called a lateral displacement. So in this case, we know that the higher the refractive index, the higher the lateral displacement. So out of A, B, C, 3 glass slabs, 1.62 has the highest refractive index. So maximum will be 1.62, that is C. Whereas minimum will be with the least refractive index 1.48, which is for A. You are given water, mustard oil, glycerin and kerosene. In which of these media a ray of light incident obliquely at the same angle would bend the most? So here we can see that glycerin has the maximum refractive index. So maximum bending of light will take place in glycerin. Light enters from air into diamond, which has refractive index 2.42. Rather, the refractive index of diamond is the maximum. Calculate the speed of light in diamond. The speed of light in air is 3 into 10 raised to 8 meter per second. So which formula we should use? N is equal to C upon V. Here 2.42 refractive index is given. 3 into 10 raised to 8 is the speed of light in air upon V. So therefore V is equal to 3 into 10 raised to 8 by 2.42. So to remove the decimal place, 242 multiplied by 100. So numerator also should be multiplied by 100. So it will be, if you solve, you will get 1.24 into 10 to the power of 8 meter per second. So this is the velocity of light in diamond, that is VD. A 4 centimeter tall object, so HO is given, is placed perpendicular to the principal axis of a convex lens of focal length 20 centimeter. F is given. If the distance of the object is 30 centimeter, so U is given. Find the position, nature and size of the image. So we have to find out the position V. Nature we can find out from that. Size of the image means HI also we have to find out. So using the lens formula, 1 by F is equal to 1 by V minus 1 by U, we can find out V. So 1 by V is equal to 1 by F plus 1 by U. We are bringing U to the other side. HO is equal to 4 centimeter. F is equal to 20 centimeter. Being convex, it is U is equal to minus 30 centimeter. U is always negative. V supposed to find out. HI also supposed to find out. So here if you substitute these values, 1 by 20 plus 1 by minus 30. LCM is 60. So this will be 3 times plus this will be minus 2 times. So 3 plus minus 2, what will you get? 1 upon 60, that is 1 by F. V will be reciprocal, that is 60 centimeter. Use the formula V by U is equal to HI upon HO. So HI is equal to V into HO by U. V is equal to 60 into HO is 4 by U is equal to minus 30. This is 2 minus 2. So minus 8 centimeter is height of the image. What is the nature of the image? Since it is minus, the image is real and inverted. And also we can find that it is double the size of the object. Object was only 4 centimeter, here it is 8 centimeter. Concave lens of focal length 20 centimeter form an image at a distance of 10 centimeter. So V is given. What is the distance of object from the lens? Same lens formula we can use. F is equal to minus 20 centimeter. Why did I take minus? Because concave lens value is negative. Focal length is negative. And V is equal to 10 centimeter. Concave lens always produce images on the same side of the object, so minus 10. So distance of object u can be found out using the lens formula. 1 by u will be 1 by v minus 1 by f. 1 by minus 10 minus 1 by minus 20. So what is the LCM here? 20 can be taken as the LCM. So it will be minus, here it will become plus, right? So here minus 2 plus 1. So minus 1 by 20. So u is minus 20 centimeter. We have to get u as minus only because u is always negative. An object of size 5 centimeter HO is given, kept at a distance 25 centimeter u from an optical center of a converging lens. Again, converging lens means the convex lens. Focal length 10 centimeter, f is given. Calculate the distance of the image, v we have to find out, and the size of the image, hi again. So same formula we can use. So here we will write first what is given. HO is equal to 5 centimeter. It is always positive. U is equal to 25 centimeter, but it is always negative. F is equal to 10 centimeter. Since it is converging lens and we found it is convex lens, it is positive, and we have to find out V, we have to find out HI. So again 1 by V is equal to 1 by F plus 1 by U. So 1 by 10 plus 1 by minus 25. So LCM if you take it is 50, we will get 5 minus 2, 3 upon 50. Therefore V is equal to 50 by 3. So 16.66 centimeter you will get V. Now HI by HO is equal to V upon U. HI is equal to V into HO by U. 16.66 into HO was 5 centimeter divided by U was minus 25. So this will go 5 times, then minus. It is negative, real and inverted image of size 3.32 centimeter. What is the power of a convex lens of focal length 40 centimeter? F is equal to plus 40 centimeter because it is convex lens. Power is reciprocal of focal length in centimeter, so we can directly write 100 by F. That is 100 upon 40, 5 by 2, 2.5 diopter. What will be the focal length of a lens whose power is given as 2D? So power is equal to plus 2 diopter, so it is convex lens. Focal length would be reciprocal of power 1 by P, that is 1 by 2 is equal to 0.5 meters, that is equal to 50 centimeter. Two lenses of power plus 2 diopter and minus 4 diopter. What is the nature of the focal length of each lens? So here first we have to find out power 1 is equal to plus 2 diopter. So focal length also we have to find out. F1 is equal to 1 by P, that is 1 by 2, 0.5 meter is equal to 50 centimeter. Now P2 is equal to minus 4 diopter. So F1 is equal to 1 by P2, 1 by minus 4 is equal to 0.25 meters, that is 25 centimeter, minus 25 centimeter. So nature with the power plus 2 diopter is convex, as its focal length and power are positive, and this is concave because its focal length and power are negative. A person having myopic eye uses a concave lens of focal length 50 centimeter. So since it is concave, focal length is minus 50 centimeter. So since it is given in centimeter, we can take power as 100 by F. That is 100 by minus 50. So minus 2 diopter. There are two lenses. One is convex lens of focal length 50 cm and the other is concave lens of focal length 25 cm. What is the power of the combination of these two lenses if placed in contact? What is the nature of this combination? So combination we can find in two ways. First we can find out the net focal length and then power, or we can find out the power separately and then add to get the total power. So let us see the first case. We will find out power first and then add it. So first step, P1 can be found out as 1 by F1. Since it is in centimeter, 100 by F1 we can write. So 100 by 50. So 2 diopter is the first one. That is convex lens. Then concave lens, focal length will be negative. So second power would be 100 by minus 25, that is minus 4 diopter. Now combination P1 plus P2 will be plus 2 diopter plus minus 4 diopter is equal to minus 2 diopter. Suppose you want to find out using focal length, net focal length would be 1 by F is equal to 1 by F1 plus 1 by F2. That is 1 by, what is first focal length? 50 centimeter plus 1 by minus 25. So LCM is 50. So 1 minus 2 minus 1 by 50. So F is equal to 50 centimeter, right? Minus 50 centimeter. Therefore power would be 100 by minus 50. So minus 2 diopter. So we got the same answer here. So either the way you can find out, but only thing is that net focal length can be found out using the formula 1 by F is equal to 1 by F1 plus 1 by F2. A convex lens of focal length 20 centimeter, so it is F is given, can produce a magnified virtual as well as real image. Is this a correct statement? If yes, where shall the object be placed in each case for obtaining these images? We know that a convex lens can produce magnified image, same size, or diminished image, and it also can produce virtual image and erect and virtual and erect and real and inverted. So if the focal length is 20 centimeter, where should we place the object in order to get a virtual image? This is the convex lens and we have the principal axis. This is the optical center, F1 to F1, F2 to F2. We know that when the object is between F1 and O, it will produce a virtual and erect image on the same side. So since here the focal length is given 20 centimeter, we have to keep the object between 0 to 20 centimeter from the lens. Second is a real image is asked, magnified real image. So in order to get magnified real image, it can be kept between 2f1 and f1. That is 2f1 will be 40 centimeter. 20 centimeter to 40 centimeter if we keep, we will get a real and a magnified image of the object. So today we discussed certain typical questions from the lens part. Please practice these questions well. All the best for your exam. Like, share and subscribe to my channel, Biology My Passion.